Today we will continue with our basic session. I think we stopped last time on the topic equilibrium. So we will continue that first, and then as we move ahead, we will see the detailed part of each and everything. So last time we have seen the equilibrium. I think some technical problem was there at the end, I think. So let's discuss again regarding that. A few more problems regarding this. Okay. So let's say, okay, am I audible clearly and no issue? Okay, shall we start?
Sir.
Okay, fine. Now, let's say, let me take one beam, horizontal beam, which is resting on, let's say, two blocks. And this beam is having, let's say, uh, having some weight on that. And that total weight, let me assume this weight as, or maybe I can say that let's have a weight at the center. W is equal to 100 kg. So if the load is at the exactly center, what will be the reaction here?
W/2.
Yeah, so half means whatever total load is there here at the center, half will go here, half will go here. So that W/2 you are saying is only applicable if the load is at the center. Okay, so let's say how much reaction will be here? 50 kg, half load. This will be half load. Let's say this is your A support and this is your B support. So is it vertical
Good
equilibrium?
evening, sir.
Good evening. So is it vertical or horizontal equilibrium?
Vertical.
So if you put it mathematically, sigma Fy is equal to 0.
सर आपका आवाज नहीं आ रहा.
हेलो, बाकी लोग का आ रहा है क्या? हेलो,
Am I audible?
Yes, sir.
Audible, sir. Audible.
Yes,
कैन
sir.
यू reconnect? You can reconnect. किसको आवाज नहीं आ रहा? So sigma Fy is equal to 0. So if I want to write this equation, generally what we say, downward is negative actually and upward is positive as far as mathematical calculations are concerned. So this 100 is minus 100 as it is downward. Then this is plus 50. And this is again upward is plus 50. And how much this value will be?
0.
0, right? So this we call it as a actually vertical equilibrium as far as this problem is concerned. Now let's talk about the horizontal equilibrium. Just I want to ask you one question. If your load is here somewhere, so which support will have more reaction? Sorry. If the load is here, which support, A or B, will have more reaction?
A will have more reaction.
Yeah, because this load is near to A, so it will have more reaction. How to calculate that we will see ahead. Okay, now let's see the horizontal equilibrium. Horizontal equilibrium. So let's say there are two people. And they are, let's say, pulling the rope. There is a rope and they are trying to pull the rope. Okay. So let's say there is a 100 kg force here. He is giving the 100 kg force, this person, and this person is also giving the 100 kg force. So is it in equilibrium? What do you say?
Yes,
Hello.
sir.
Yes, because they both are pulling by the same force. That means it is in equilibrium. Otherwise, let's say this person is pulling by 200. What will happen? What will happen?
It will move in
Left,
side.
leftward.
Left side.
And as it is moving left side, we cannot say that it is in equilibrium, isn't it? Because there is a movement, it is not static. Equilibrium means we are talking static equilibrium, please keep in mind. That means the object should be stationary. In that case, only say, see here, we have seen this beam. Why this beam? Will this beam be stationary or not?
Yes.
Yes, sir.
It will be
Stationary.
stationary because both supports are giving.
Am I audible? Anyone?
Yes, yes. Are we audible?
Yes, sir.
Yes, sir.
So as these two reactions are equal, means they are giving equal and opposite to this vertical load, and due to that it is statically in equilibrium. Okay, so we can say stationary object. In the similar way, if this is 200, this is 100, then this person will pull this person into the left side. Okay, and in that case we cannot say that it is equilibrium. So if this system we want this system to be equilibrium, then this force also should be 100 kg. So if it is 100 kg, then we can say it is a equilibrium. And this, as the direction is horizontal, we can say horizontal equilibrium, which we can put like this mathematically. So this left side, generally in left side we take negative, and to the right side we take positive in calculations. So minus 100 plus 100. This is minus, this is plus, is equal to 0. Okay, so this is horizontal equilibrium. Now let's say again one more example. If we have a block resting like this, and there is a weight to that, vertical weight, and let's say there is a horizontal force also, P. So can you say that it is equilibrium, or which part is equilibrium?
Sir, this is not an equilibrium.
Equilibrium, but in only vertical direction. For this W, there is a ground actually who is giving the reaction to that. So this
Okay.
RV is there. So vertically, I can say that sigma Fy is equal to 0 holds good, right? And which is nothing but this reaction. How much the reaction will be? It will be R will be equal to W only for equilibrium, isn't it? And we can say W minus W, this one, plus W is equal to 0, right? So Fy is okay. Now what happens to the Fx? Sigma Fx is equal to, is it correct or not? So there is a P force to the right side, P. Is there anybody who is resisting the horizontal load?
No.
No. That means P is not equal to 0. As P is not equal to 0, that means this equation is not. So no equilibrium, no horizontal equilibrium. So keep this in mind. So that means what will happen to this object? This will move to the right side, let's say like this. This will move. And as it is moving, then we cannot say that it is equilibrium. So let's say if you want to make it equilibrium, what can you do?
So equal and opposite load,
So-
same load.
Opposite horizontal force
There has
can
to be
be applied.
somebody, yeah. So either opposite horizontal force can be applied, Okay, there
Equal
has
and
to be
opposite.
somebody who will give the reaction, right? So let's say this way here, this ground was giving the reaction. Let's say create one wall over here, and that wall will give the reaction. So this W, and this will be W, this will be P, right? Now this wall is giving the support to this block. So if you put any block at the corner of the wall, the ground will give the reaction vertically, and this wall will give the reaction horizontally in the opposite direction. In this
That
case,
should be equal, na?
yes,
Equal
it should
force.
equal force.
It should-
P and P same,
Yes, yes.
right?
Then
So
only-
in this case, sigma Fy is equal to 0, which is minus W plus W,
Minus
equal
P plus P.
and sigma Fx is equal to 0. You can say,
Minus P.
okay, you can start from anywhere, plus P, minus P, okay. So this is the equilibrium equation. Now let's say one more example. Now this was over with respect to the horizontal and vertical reactions. So we can take one more example. Okay, let's see this. Say we have one block over here. Okay. And let's say there is a hole there is a hole or bolt, we can say. There is a bolt, and now we are applying one force over here, which is nothing but horizontal force is P here. Okay. And this block will have weight, which is vertically downward W weight for this block. And we are applying one horizontal force over here. Now tell me, is it equilibrium or not? Who is giving the support? This pin or bolt. This bolt is giving the support. Huh? Please try to understand. Where is the load where the load will transfer?
So this load can be
So this
transferred to
bolt,
ground.
it
na?
will transfer to this vertical
Ground.
pillar.
Yes.
So
yes.
the bolt is important. The point of reaction or point of support is this point. Huh? Please try to see, understand. So bolt is there. Let's say we are putting bolt. Now, is it equilibrium? If this is W, who will give the reaction vertically?
Oh, vertical.
So there will be one vertical reaction at this point, which is W, isn't it? And will there be any horizontal reaction here? As this horizontal force is there, definitely it will offer one horizontal reaction, which is P. So I can say that sigma Fy is equal to 0 is correct, because minus W plus W equal to 0. And sigma Fx is 0, it is also okay. Which is plus P and minus P. Anything else here? What will happen to this block?
Sir, it will rotate.
Yes, it will rotate. That means, because see, the load is not applied at the center here to this line. So that means it is going to rotate like this. Right, it will rotate like this. This will be the rotation. As it is rotating, can we say that it is equilibrium?
No, sir.
No, sir.
Yeah, so it will not. So we can say, as it is rotating, there is third equation. This is the first equation, Fx, then second equation, Fy, and there is a third equation, you know that, which is nothing but sigma m moment. Now in this case, it is not, is it 0? No. Let's say we have a distance A, height of this block is, let's say, A. That means what is the moment value? P into A. Moment is P into A. And as there is nobody to resist this, that means the value of the moment is how much? P into A, which is not equal to. That means body will rotate, which you can see. And as it will rotate, as there is a moment, the moment equilibrium. So it is not equilibrium. Only two equations are there who are equilibrium. Now, if you want to make this moment equilibrium, what will you do? Any suggestion to this problem? Now, you want to make it equilibrium. So for the time being, I will just remove this rotation. Tell me, any suggestion to make it so that it will not rotate?
So we can replace the bolt by welding so
No.
that it will not rotate.
But that is not a right solution, I think, because see, whenever we have a bolt, it is having a very small diameter, isn't it? So even the weld will try to rotate. Means as it is very small. If it is very big portion like this, if you prepare like this, I can say, okay, your solution may be correct.
So same load we will put
that
right
is
hand
the
side,
yes,
right hand side, lower end.
Lower end, yeah. So that will be good solution. Yes, you can do the weld as you said, but there has to be bigger size of the, we can say. So it should be big then. There should not be bolt, but there should be some solid plate like this, which is welded, and then you can say. And instead of that, there is one more good solution for this will be put this force. Right, this one. Now what is happening? Now try to write down the equation. So P into A. So sigma M is equal to P into A. P into A.
Minus P into A.
Yeah. Now this is clockwise. It is giving
Yes.
clockwise moment, and here it is giving anti-clockwise. So minus P into A. What will be the value at the end?
0.
Now it is equilibrium, right? Now it will not rotate. So this is the, we can say, three equations of equilibrium which we use. So in our structure engineering, make sure that all three equations are satisfied. Then your structure will be stationary. And we already discussed that whatever structural engineering we are learning now, they are all stationary objects. It may be bridges, buildings, or retaining walls, or steel structures. Whatever structures you are taking, they are stationary structures. That means they follow these three equations of equilibrium.
Sir, I have a doubt in
Yes.
this. Both the moments are in clockwise direction only about the hinge.
Yes, the arrow should be different.
So arrow should be on the left side, the lower one, P also.
Yes. It should be different. It is giving wrong. Because this is clockwise, we want anti-clockwise. So I can say
Yes, sir.
that it has to be like this. Right? Is it okay? Is it okay?
Yes, sir.
Yeah. They should be like this, because then it will have an anti-clockwise moment. This is clockwise, this is anti-clockwise. Correct. Or there can be one more solution. We can say if this distance is also A, let's say. So either put here or here also, isn't it? Will it be okay? Because this distance is also A, so it will be P into
Yes,
A,
sir.
right? So either put this force here in this direction or this, okay? If
Sir,
you
then,
put this,
if you put the P in vertical direction, then vertical equilibrium will be satisfied.
So actually in this case, it is nothing to do with that. We are talking about this one.
Okay.
So what will be the value? Yeah. Right. So this load is passing through the support. Please try to see. When it is away from the support, it will create moment actually. Right. Now let's see second example. You will understand in that case. Now here. Now we are little moving ahead with the so let's say we have one example and there is one person, let's say here there is one person sitting. Okay. And there is one child sitting here. And the load of this person is child is 50 kg and this person is having weight as let's say 100 kg. Okay. And the distance between this each person, this one is 4 meters and this one is okay. So is it equilibrium?
Yes, sir.
Yes,
Yes,
sir.
sir.
So you can say moment, we can take moment about any point. Let's say take the moment at this point. So what is the moment? So this 50 will have anti-clockwise, yes. This 50 will have anti-clockwise and this 100 will have clockwise. So what will be the sigma m? 50 into anti-clockwise. Now you can assume whatever we can say. Let's say anti-clockwise is positive and clockwise is negative. Okay. So
15 to
positive
4.
means 50 into
4,
4 and this is minus.
102.
So what is the value? 0. So that is it is moment is balanced. So generally we call it as a couple, a balancing couple. Now let's say if we have the weight of this person is 50, instead of 50, let's say it is 25. What will happen?
Minus 100. Minus 100.
So what is this moment of this left side moment will be 25 into 4
4.
and this will be 100 into 2. So 25 into 4 is how much? 100
100
and this
minus
is 200. So what is the value actually? Minus 100. So there is a unbalanced moment. This moment you can call it as an unbalanced moment. Unbalanced. And not equilibrium, not equal to 0. And what will happen to this rod? This horizontal rod is or platform is there. What will happen to this?
It will lower down on the heavier side.
So here in this side it will lower down, right? Because this moment
Yes,
is
sir.
more. Right side moment is more, so it will try to. So this will be like this seesaw. Seesaw will be like this. Something like this. Okay. Because the right side moment will be more, and this will go up then, right? So this is the moment equilibrium we can say.
Yes, sir.
Okay. Now we will switch on to the next topic, which is supports. So all of you know that in any structures there are supports who are resisting either reaction loads or moments. So let me give one example. So there is one rod and there is one block over here, right? And let's say there is one. This is ground, and let's say we have this rollers, and this is having one weight. Let's say we have a weight, which is W. And let's say we have one horizontal load here, which is H. So what will happen in this system? Which kind of
Will move
equilibrium is there?
horizontally.
It will move horizontally, and will it move downward?
No.
No. So
No, sir.
definitely, because there are supports actually giving the resistance in the vertical direction. So let's say it is R1, R2, whatever you want to say. So there is a reaction here available, but horizontally there is no reaction because this roller is moving in the right direction and there is nobody resisting in this direction. So this support, what support we call it as? What kind of support is this? We are calling
Roller
it
support.
a roller support. So roller support is giving vertical resistance, right? Vertically it can take the load, but can it take the load in the horizontal direction? No.
No, sir.
So in this case, we can say vertical reaction is possible in roller supports. Vertical reaction possible. But can there be horizontal reaction? No horizontal reaction because the roller will move. So no horizontal reaction. So no horizontal reaction means what is the meaning of it? Cannot resist horizontal load. Cannot resist horizontal load. And vertical reaction possible, that means can resist vertical load. Are you getting? Now, can this resist the moment? Can this support resist the moment or rotation? Correct?
No, sir.
Yeah. So how do I understand this? Whether it will not resist? It will not resist moment. It will rotate. So it will not resist rotation. So we can say will not resist rotation. How can you show this that it is not it is not resisting rotation? How can you show? So we can show like this. We can say something due to vertical load, what will happen? This will try to bend. Like this. Now, if you look at this picture, how can you say that it is not resisting the rotation?
Because there is a curvature.
Yes. So you can say, see, this is the bottom of black line. You can see this bottom of this beam, and this is also red. This one is also bottom, and this one is also bottom. Show this. Okay. So this is a bottom line. Previously it was like this, yes or no? So this previously this line was like this. Now it is like this. That means it got rotated here at the support point. Please keep in mind what I'm telling. At the support, if you see, the line was horizontal here, but now at the support the line got inclined. That means it got rotated like this by some angle, whatever maybe, I don't know. So that means at the support is not resisting any rotation. That means it cannot carry any moment at the support. Are you getting this? समझ में आया मैं क्या बोल रहा हूँ?
Yes, sir.
Support point is very much important. So this is, that means it will not resist rotation. That means what is moment is zero at this point. Moment means resisting moment, we can say. It cannot resist moment, so it is zero because it is going to rotate. So there will be vertical reaction, there will not be any horizontal reaction, and there will not be any moment also. Correct? Got this?
Yes, sir.
So see, moment is a kind of reaction, what we are doing. So moment is zero means m is equal to zero, I can write. Then no horizontal reaction means and no vertical reaction is possible. So these vertical reactions are there, right? But there is no horizontal reactions because there is no support to there is no support to this support, the roller, okay, to the right direction. Now let's see second example of the roller support itself, smaller example. So whenever I draw a roller, it has to be drawn in this. Let's say we have one rod like this, okay. So is it a roller support or hinge support? What do I understand?
Hinge support.
Okay. So how do you say that it is hinge support? Let's say you are giving load here. Let's say I'm putting load like this, P. Will there be any reaction in the horizontal direction?
Equal and opposite.
When you push
Yes.
this bolt will try to resist so that this blue color rod will not move in the left side. See this, what is the tendency due to this load P? The rod will try to go on the left side, but there is somebody who is resisting that horizontal movement. Who is resisting that?
Hinge.
कौन resist कर रहा है horizontal movement को?
The bolt.
Bolt. So there will be reaction of the bolt to the right side, and due to that, we can say there is a equilibrium, horizontal equilibrium. Apex. So that means horizontal reaction is possible here, right? Horizontal reaction possible. as horizontal reaction is possible, will it move this? Will the rod will move in the left side? Will it move?
No.
No,
that
sir.
means I can say horizontal displacement is absent. Right. Now, let's say we have a load. Now it is unstable structure, but for the understanding purpose, let's say I have a load like this V. Can this vertical load be resisted?
No, sir.
Vertical load I am talking. Will this rod move vertically downward like this? Let me show this. See, if you say that it will not resist, will it resist vertical load?
No.
Yeah. So just conceptually, what I am trying to say, will this rod move like this? Abhi yahan tha, abhi now after moment it is here somewhere. Will it be possible like this? Because
No.
vertical load से ये यहाँ आएगा क्या horizontal? यहाँ
No.
से
No,
यहाँ
sir.
आएगा.
Moment only.
It will not translate like this because there is a bolt available. So this bolt is not going to move this rod like this vertically, uniformly vertical displacement is not possible due to this bolt. That means I can say there will be reaction in this direction also. The value will be, let's say, V for the time being. That means we can say vertical reaction possible. Why it is possible? Because vertical displacement is absent. This point will not move down. So this rod portion will not move down at the support level. Will it go down? No.
No.
So vertical displacement absent. So I can write this P as whatever reaction. This is horizontal reaction. I can name this as horizontal reaction RH. Let's say this P value RH and this is RV. Just technical terms I want to write here. Okay. But yes, what will happen to this V, to this rod now? It will
Moment. Wait moment.
it will rotate. So either it will rotate like this. Right. So it will rotate. So like this. That means at this point there is a rotation available at this point, at the support point it is rotating. Please keep in mind, whenever you say rotate, don't look here, look at this point. The support is rotating. Not support, at the support the member is rotating. Okay. That means rotation is possible. Possible. And as rotation is possible, moment is zero. Moment is absent. Absent. So I would say at this point there will be reaction RH, there will be reaction RV, but the moment will be zero. So moment is zero, but two reactions are possible. And this support we call it as a hinge support, right? Hinged. You can say hinge, you can say pinned, whatever you. And that's why I'm showing this as a pin. Pin means bolt, or we can say pin here, right? So this is a hinge support. Previously what we discussed, it was a roller support. It can only have vertical reaction, so no horizontal reaction possible. So M is 0, H is 0 in the roller support, and V is okay. There will be some reaction. V value will be there, some value. And in hinge, RH is possible, horizontal reaction, vertical reaction is there, but moment is 0. Now let's move on to the next supporting condition. See, this topic is very much important in structural engineering. So if you don't understand conceptually and fundamentally, then say whenever you take decisions in practice, there may be, say, big mistake whenever you detail the supports, or whenever you do the analysis in softwares or manually also, whatever. So in analysis, in design and in drawings, the supporting condition should match. It should not happen that in analysis you are assuming, let's say you are doing the ETAP model or STAT model, and you in the analysis you are considering your support as let's say fix, and in design you are doing as a hinge, and in drawing also, let's say you are detailing the reinforcement such that it is behaving like a hinge, but it will be wrong because your analysis is saying it is a fix, but you are doing it as a hinge. So the behavior of the structure will change. So that means at every level, it may be analysis, it may be design or drawing, your assumption should hold good. So assumption at every level should be same. If you are assuming fixed, design it as a fixed, and also do the drawing and detailing such that it will follow the fixed supporting conditions. Are you getting? Yes, so that meaning you will understand ahead. Now let's go. We have seen roller support, hinge support. Now let's go to the fixed supports. So fixed support. Okay, let's do one thing. Let's say I have one beam. You can say this beam is steel beam is there. You can say assume steel beam which is embedded in the concrete. So this is a whole concrete portion. Okay. So it is embedded in the concrete, this steel beam or rod we can say. Now let's say I have a load here like this P. And this is the support. And look at the support now. Now if I try to, let's say, pull in the horizontal direction, will this rod go out?
No, sir.
Because there is somebody who is giving resisting this horizontal movement. So horizontal movement or horizontal displacement is not possible because here this rod is embedded in the concrete, and at this portion there is a reaction. Now it will be opposite reaction. So the reaction direction will be like this, because this is trying to take this rod out and this support is trying to take this rod left. So let's say we have a horizontal reaction RH. So due to this reaction, due to this embedment, the rod will not move to the right side. So there is a reaction available in the horizontal direction RH. Correct. Now will this rod move down? Support से down होगा क्या ये? Will it move like this? Sorry.
No, sir.
From this, will this move like this? Move होगा? नहीं होगा ना? ऐसे vertically. Linearly it will not move because within this zone it is embedded in this concrete. So this portion will not. So there will be vertical reaction. Why? Because there is a vertical reaction developed at the concrete due to this concrete portion. So there is a RV, let's say, so vertical, because that means this will not move down, this will not move rightward. So this will not move horizontally, it will not move vertically also. That's why the reactions will develop there. RV vertically, RH horizontally. Now, anything else that will happen to this? Now let me remove this for the time being. Oh, let it be. Okay. What will happen to this now?
There will be movement reaction also.
It will try to bend. Will it try to bend? Yes. Now, as I already told you, when it rotates, will it rotate? जैसे ये
No,
rotate
sir.
हो रहा, ये rotate हो रहा था, ऐसे होगा क्या?
No, sir.
Will it bend or displace?
Bend.
या तो bend हो रहा है तो
Bend
फिर
होगा.
Yeah, bend hoga, but then when it is a bend, there is a rotation, and when there is a rotation, we say moment is zero. तो है क्या इधर फिर moment zero?
Only deflection will be there.
So moment
No.
moment zero रहेगा या moment रहेगा support पे कुछ?
रहेगा सर.
Yes, because now please keep in mind we are talking of the supports. That's why I told you here, look at the support, don't look at somewhere outside. See, this rotation I'm showing is here, but actually here also you can see there is a rotation in this direction. So previously this line was here, this blue line, and now there is this inclined line. So at the support, there is a theta here. Please keep in mind. Don't look at this. Let me remove this itself. Don't look this theta here. See this here. Okay, it's very important because at this point it is rotating. Now here in this case, what will happen as it is embedded in the concrete, it will not rotate here, but now let me draw the deflection diagram. So I can say this will not rotate here, so it will be horizontal only. Okay, at this supporting, near to the support we can say, and after that point it will bend. Okay. So this is horizontal. This portion is horizontal, which is maintaining the 90 degree angle. This is also horizontal, maintaining the 90 degree. But after that, it is trying to rotate. So the rotation is there, but not near at the support, but away from the support. Somewhere from here, it will try to have the rotation. There is a rotation, yes, theta rotation is there, definitely yes, but not at the support. As the support, at the support, it is not rotating. I can call this as there is a possibility of moment M. That means moment is not zero at the support. So I can say here horizontal and vertical reaction possible hai kya? Horizontal reaction possible. Why? Why horizontal reaction possible? Because horizontal displacement is not. Horizontal displacement is not possible, and therefore it is not possible. So it cannot go out, or it cannot go even inside also. If you push this horizontally in this direction, it will not go inside, and if you pull this outside, it will not go out. So horizontal displacement not possible, and as it is not possible, the reaction will be there. So somebody is resisting that displacement, isn't it? And therefore RH will be there, reaction H will be there. Then second case is vertical reaction possible. Why?
Not displaced.
Vertical displacement is not possible, that's why. So RV will be there. And you can say, as it is not rotating at the support, the 90 degree, whatever the angle was there, it was horizontal, it is there horizontally even after bending. And therefore, moment is possible. Because rotation is not possible at support. Rotation not possible at support. At support. At support is very important word. Because after support it is rotating. At support it is not. So I can say there will be M also. There will be three reactions, RH, RV, and M. And this support, we call it as a fixed support. I hope you got all this. Getting?
Yes, sir.
Yeah, so there can be one more example of fixed support. ऐसा भी कर सकते हैं. So you might have seen, generally in concrete, we support the steel beams. आपने कभी देखा होगा concrete beams में, concrete में, either it is concrete column or a concrete beam, we can have support the steel beams. So generally semi example hai. Let me show that. Let's say there is a concrete column or wall. Let's say concrete column है यहाँ ऐसे कुछ तो. There is a concrete column and I want to create one cantilever. ऐसे कुछ तो cantilever करना है मुझे, समझो, support करना है मुझे let's say I want to create one balcony here. तो इसके लिए मुझे support करना है column को. तो cantilever so okay, let me show you one example. Cantilever का example मैं देता हूँ एक थोड़ा अलग से. Just tell me whether it is possible or not. ऐसे cantilever मैं बना रहा हूँ. ऐसे एक लोड है. So is it okay?
No, sir.
Why?
Because there is a rotation
Yes.
at the support.
Yes. So at the support, actually, okay, there will be reaction like this, but it cannot be at the same position. It will rotate. ऐसे कुछ तो rotate होगा. That means, can I say that it is a cantilever? Is it a cantilever? No. Is it a stable structure? A stable है क्या?
No, sir.
No,
So
sir.
it's not stable. And we are not designing any unstable structures. Okay, so it is not stable. So if you want to do the analysis of any structure, first you should make it stable. So make it stable. So every structure can be made stable by different supporting conditions. So make it stable. So how can I make it stable? Why it is rotating? ये rotate क्यों हो रहा है? This is not bending, it is rotating. Please, the words are different. Bending word is different and rotate is different. Huh? There is a bending and there is a rotation. The full horizontal beam is rotating fully. Okay. So this is called as the rotation. And as it cannot resist the rotation, therefore it is unstable actually. Because there will be excessive deflection. इतना नहीं, ये तो actually in reality क्या होगा पता है कि इसका? In reality ये नीचे ही आएगा, इतना भी रुकेगा नहीं, ये almost ऐसे गिरेगा. Let me show this. This will be something like ऐसे गिरेगा ना नीचे. Yes or no? पूरा ऐसे. It will fall down. Yes. So it is unstable. So how can you make it stable then? Why it is rotating? The question was why it is rotating.
Pin joint because of pin.
It is rotating because there is nobody to resist the rotation. There has to be somebody who will resist this rotation. That means there has to be some moment of resistance at the support available, right? So you should make such an arrangement of the support who will resist the rotation. And whenever you resist the rotation, there will be moment possible at the support, right? Now let's go to this problem again. Now, so I want to attach this steel beam to this RCC column. And definitely I want to make it stable first. So whenever you say cantilever, how can you make it stable? There has to be some reaction which is RV, vertical reaction should be there. So you should support it vertically first. So create such arrangement which will give the vertical reaction and which will avoid the vertical displacement. Again, create such arrangement which will give horizontal reaction. That means this rod will not move horizontally. So there should not be any horizontal movement like this. There should not be any vertical movement, and there should not be any movement also, rotation also, right? Now, how will you create such an arrangement which will have vertical reaction, horizontal reaction, and which will have a moment of resistance also? कैसे मिलेगा इसको बताओ? Any idea?
By embedding the reinforcement into the supports.
Yeah, so there is one question that this is a steel beam, quite deep beam you can say. Let's say steel beam, or I can say this beam in cross section. Let's say it is a tube, like rectangular tube ऐसे समझते. Let's say this is a rectangular or square tube. ऐसे कुछ तो है समझो. This is a square tube. Okay. This is not a reinforcement or rod, just it's a square tube. I want to attach this to this column because I want some load यहाँ कुछ तो देना है, balcony बनाना है समझो. तो अभी कैसे करेंगे इसको? So यहाँ पहले मुझे वर्टिकली उसको सपोर्ट करना होगा. So वर्टिकल अरेंजमेंट के लिए से अभी मैं बताता हूँ, बट so एक प्लेट लगाता हूँ मैं यहाँ. Let me put one plate over here. Like this. Okay, so I will attach one steel plate, embed the steel plate into the column, right? ये समझो स्टील प्लेट है हमारा. अभी हाउ टू अटैच स्टील प्लेट को? यहाँ तो थोड़ा वेल्ड करेंगे, बट वेल्डिंग विल नॉट बी सफिशिएंट हियर इन दिस केस. ओके, यहाँ वेल्ड करेंगे, देयर इज नो प्रॉब्लम. दिस इज नॉट ओनली सफिशिएंट केस. वी कैन से आई विल पुट वन बोल्ट ओवर हियर. यहाँ ऐसे बोल्ट लगाएंगे, राइट? So I will put one bolt over here, one bolt over here. से कुछ तो bolting करेंगे इस प्लेट को, correct? और यहाँ weld करना पड़ेगा. Now, if I have a load like this, will there be any vertical reaction? है क्या possible? Load कहाँ से कहाँ जा रहा है? So from this point, through this welding, the load will transfer in the plate. Okay, and the plate we have a bolt, so there will be vertical reaction. यहाँ reaction available होगी, yes or no? These bolts are providing the vertical reaction. Let's say ये P है तो P/2A रहेगा. Half load will taken by the one bolt and half load will be taken by second bolt, P/2, right? So I'm creating this arrangement. Now again, as these bolts are embedded in the column and they are connected to the plate, and plate is connected to the beam, there will be horizontal reaction also. So यहाँ reaction horizontal भी रहेगा. अभी in this case we don't have any horizontal reaction, so this H will be 0 in this case. But if we have, let's say ऐसे कुछ तो load है horizontal H, so this bolt will have half load H/2 and half load H/2, right? Are you getting? So
Yes,
horizontal
sir.
ये रिएक्शन हो गया, ये रिएक्शन. नाउ मोमेंट कैसे रेजिस्ट हो रहा है अभी बताओ. नाउ दिस इज अ क्रिटिकल पॉइंट. और द मोमेंट इज गेटिंग रेजिस्टेड. See what will be the moment due to this load? What will be the moment? Let's say I have this span as L span है मेरा. मोमेंट कितना है मेरा बाहर से? एक्सटर्नल
P into L.
Yes, P into L will be the external moment due to the load, external loads. Now who is resisting the moment now? इतना ही मेरा कितना मोमेंट का वैल्यू कितना है? P into L है. समझो P का वैल्यू मैं पकड़ता हूँ 10 किलो न्यूटन and L let's say हमारा 2 मीटर है. So how much will be my moment? 10 into 20. 10 into 2 ना, 20 kilonewton meter. Yes, so this will be the moment, and somebody has to resist at the support. The support should resist this moment. Then and then we have a equilibrium equation, right? So कैसे होगा इसे resist? Resistance कैसे हो रहा है?
Through the bolts.
Yes, now see moment से क्या होने वाला है? अभी थोड़ा visualize करो. So due to this moment see क्या होगा? ये bend होने, this portion will try to come out. Yes or no? So as
Yes,
it is,
sir.
this line top chord we can say is trying to come out of this. Yes or no?
Yes, sir.
So ये बाहर जाने का ट्राई कर रहा है, इसका मतलब ये बोल्ट should resist in this direction. Yes or no? ऐसे. So there has
Yes,
to be.
sir.
हाँ, तो ये बाहर जाएगा तो ये कोई तो चाहिए जो यहाँ से पुल करेगा इसको. This is trying to go out, so this bolt will try to hold it in the left side. That means ये फोर्स को इसने बैलेंस किया और रेजिस्ट किया we can say. अभी ये क्या होगा इसका पोर्शन, ये पोर्शन को क्या होगा? This portion will try to go inside. Yes or no? Imagine हो रहा है ना सब?
Yes, yes, yes.
As this is
Yes,
going
sir.
trying to go out, इसका मतलब यहाँ से ये बोल्ट ऐसे रिएक्शन देगा इसको उल्टा. करेक्ट?
Okay.
दैट मीन्स ये जो फोर्स है यहाँ, लेट मी कॉल दिस, अभी 2 मिनट के लिए मैं हॉरिजॉन्टल रिएक्शन को भूल जाता हूँ, छोड़ दो इसको. 2 मिनट रहेगा तो ये रहेंगे h/2, नहीं रहेगा तो कोई नहीं रहेगा यहाँ, क्योंकि हॉरिजॉन्टल फोर्स ही नहीं तो हॉरिजॉन्टल रिएक्शन की जरूरत नहीं है फॉर द टाइम भी. यस इट इज, अगर आएगा कोई तो फिर लेगा ये बोल्ट. नाउ यू विल सी दिस बोल्ट इज गिविंग दिस रिएक्शन, एंड ये बोल्ट है मेरा, ये ऐसे रिएक्शन है, ये बोल्ट, 2 बोल्ट. Now as it is a symmetric location of the bolt, let me call this as a F, and this is also F. Okay, but there will be force, and let's say ये दोनों का distance है D. So who is resisting now? Can you imagine that there is a couple formation here? ये ऐसे left को जा रहा है, ये right को जा रहा है. So there is a moment of resistance. ये M develop हो रहा है कि नहीं? This M is resisting moment. So this is your action we can say. This moment is action due to the loads, and this is your resistance or reaction. So moment reaction we can say. This MR is, and who is creating that reaction? This F at opposite direction with distance D. That means couple form कर रही है. So ये moment का value क्या रहेगा? MR is equal to how much? MR is how much? F into D.
F into D.
So F into D will be the moment of resistance. So ये moment को resist कर रहा है ये वाला value. समझो हमारे distance between the two bolt is let's say 0.5 meters है समझो. Okay, D is 0.5 meters. So what will be the force value F? So equilibrium equation डाल देंगे हम. So let's say इस point पे हम equilibrium equation बनाएंगे. ये point A है समझो, supporting point. So how the abhi, if you take the moment at this point, then let's say moment at this point, and we know that for equilibrium it has to be 0. Moment at A is equal to 0. So external moment P into L, हमारा कितना है? P into P मतलब let me write P into L. अभी assumption क्या करेंगे हम? clockwise को positive करेंगे. ठीक है, let's say your clockwise moment is positive and anti-clockwise moment is negative. Okay, you can assume anything, there is no problem. So this is negative, this is positive. So P into L क्या होगा मेरा positive या negative? Clockwise है ना moment ये ऐसे rotate करेगा ना इसको. Yes.
Yes, sir.
So this M value will be positive. So it is positive P into L. And ये कैसे कर रहा है? देखो ये arrow ऐसे और ये ऐसे. So this is creating anti-clockwise. So minus F into D. It has to be 0. तो अभी हमारा P वैल्यू है 10, L वैल्यू है 2 और F I don't know and D कितना है? Has to be 0. अभी units are important, don't forget the units. D हमारा 0.5 है, so I want to calculate the force F. So कितना आएगा F?
10.
So मैं बहुत ही 20 ये 20 होगा, ये minus 0.5 into F आएगा, तो right side को गया तो it will be F into 0.5.
4.
So F will be, sorry ये F है, F will be 20 upon 0.5. कितना आएगा? 40 आएगा ना?
40.
40.
40.
40
यूनिट क्या रहेगा इसका?
Newton.
kilonewton.
So this 10 is kilonewton, this 2 is meter, this F is kilonewton, and this 0.5 is meter. So as we are dividing, meter is going actually, right? So it is kilonewton meter. So this 20 is, again now let me write it, 20 divided by 0.5. Na? So 20 is having the unit of kilonewton meter because this into this kilonewton into meter, and 0.5 is a meter. So finally this is cancelled and 40 kilonewton. That means these two bolts are taking the vertical reaction, they can take the horizontal reaction, and they can take this moment also. I hope you got this. And this is the fixed support, practically speaking. समझ में आया support?
Yes, sir.
So this is the fixed support because three reactions are possible. Moment of resistance is there, MR. So this is also one reaction. Moment reaction is possible, vertical reaction is possible, and horizontal reaction is also possible. अभी यहाँ नहीं है, लेकिन I can draw that H वाला था ना. Because bolt इस side को भी move नहीं करके देगा, so H will be also there, right? Conceptually, if you understand this, then you can think of how it is done practically. Once you understand what is meant by support, then you should know how to apply on the real problems. So real problem ये एक हो गया moment connection का. Now let's see practically how to do this. So this is one practical example. Let's see some more examples of practice. Let me draw now. So have you seen I section beams like that? Practice में कभी देखा है I section beams? I beams are there. Let me partially show this. This is a break line. If I don't want to show the total column, this is a column. And if you ask me what is the cross section of this column, so this is a I-beam, I can say. So I-beam आपको पता है कैसे ऐसे रहता है. Okay, ये और both are same. This is I section, ISMB. ISMB 400, 300, you might have seen that kind of sections. So this is a I section column. This is also I section column. And now I am connecting a beam to this. Which is also I section. Same I section is like this. The beam section is like this. Now tell me how to make this simply supported. Matlab simply supported means hinge. I want hinge here, I want hinge here. That means I don't want to create any moment here. Hinge means what? No moment. Yes or no? So मुझे ये दोनों support को hinge करना है practically. अभी hinge का meaning क्या आपको पता है? What is mean by hinge? बताओ.
Where vertical and horizontal reaction are there and rotation is possible. Add support.
RV मतलब vertical reaction, RH means horizontal reaction, but moment is not possible. Moment is zero, right? Moment
Yes,
is zero. Reaction is there, some value will be there. Horizontal reaction will be there, some value, and vertical reaction value will be there, but moment is zero because it is rotating. At this point, it will rotate. Now tell me, how will you make this as a hinge? Now, last time here we have seen that if I do this like this, अगर plate वगैरह लगा के ये bolt किया ऐसे, तो there will be some force F like this. So there will be moment possible. Yes or no? Moment रहेगा ना इस केस में. Moment of resistance,
Yes,
action of support. So we cannot say that it is a hinge. ये नहीं रहेगा तो ही possible है. इसका मतलब क्या करना है आपको? ये दोनों को avoid करना है. There should not be such arrangement which will create these two opposite forces. ये force होना ही नहीं चाहिए उधर. क्या कैसे करेंगे बताओ? अभी hinge तो आपने किया है, मतलब hinge का meaning ये hinge है ना हमारा. ये
Welding only.
Standard bolting system.
अभी see conceptually try to understand. मुझे ऐसे करना है कि इसको कनेक्ट तो करना है. अभी प्योरली बोलता हूं मैं. प्योरली अगर मुझे करना होगा तो कैसे करेंगे? जस्ट लेट्स से ये थोड़ा निकलता हूं मैं इसको. रियली स्पीकिंग
Welding की तरह.
एग्जैक्टली अगर पिन करना होगा तो मैं थोड़ा ये दिखाता हूँ. एग्जैक्टली करना होगा तो यहाँ मैं एक कुछ तो ऐसे कुछ तो ये ऐसे प्लेट लगाऊंगा और यहाँ एक बोल्ट होल करूंगा यहाँ, राइट? ये प्लेट है, यहाँ एक होल किया मैंने इस प्लेट को, एंड देन अभी ये ऐसे यहाँ से ऐसे करूंगा मैं इसको. पहले मैं टोटली थियोरेटिकल दिखा रहा हूँ. ओके, ये ऐसे कट करके ये ऐसे कट करूंगा और ये वेब है ना, वेब को मैं ऐसे टर्न करके एंड देन आई विल क्रिएट अ होल टू दिस वेब आल्सो. ये वेब है ना, इसको होल करूंगा यहाँ ऐसे कुछ तो, राइट? सो देयर इज अ होल टू दिस प्लेट. there is a hole to this web of this beam, and I will put one bolt over here, right? Correct. Similarly over here. Getting? अभी ये मोमेंट करेगा कैरी? मोमेंट रहेगा कि इस केस में?
No, sir.
So it will, as we have discussed, ये ऐसे कुछ तो बेंड होगा, ऐसे और ये सपोर्ट के यहाँ पे ऐसे नहीं कि ऐसे बेंड होगा, क्योंकि ये पोर्शन पे भी ये बेंड हो रहा है ऐसे, राइट? ये this is rotating, you can see here, ये line, this line is inclined, so that means there is no possible moment possible there. That means rotation is possible at the support. So this can be the case, yes or no? And this bolt can resist vertical reaction, which is, let's say, RV. Will this beam go out? Will this beam go out?
No, sir.
There will be reaction RH. It will not even go down at the support, so it will be RV. But yes, it will rotate at the support. So moment is 0 in this case. So there is a RV, there is a RH. So this can be the case. Now see, preparation of this kind of curvature and all these things really not possible practically. Okay, so I will show you how it is made practically. So already I have told you structural engineering is an approximate science. So there will not be any exact theoretical calculation and real detailing like that. So there will be little error, little difference in reality and in your analysis. Please try to understand. I will tell you how to handle that and all these things and how we make those safe structures. Now अभी ये कैसे बनाते हैं? How to make this? So see, this sections comes in straight line actually. So what we do in this case, generally क्या करते हैं हम पता है क्या? ये ऐसे रहेगा. Then I am cutting this flange. ये flange है नहीं, this flange. I am not taking this till this end. And then web and a web portion as a small web portion I will cut it. Okay, and यहाँ I will put bolting arrangement. यहाँ plate करूँगा ऐसे and I will put one bolt over here, right? Getting this? Are you getting? So I am cutting this wave like this and smaller portion I am keeping. And then due to the load, this will try to bend. So it is not exact hinge. क्योंकि यहाँ थोड़ा तो depth मुझे देना पड़ेगा ना. But yes, I can say it is more hinge, near to the hinge. अभी generally, practically, we cannot have a practically 100% hinge is not possible. Only that bolting, अगर ये करेंगे ना तो 100% hinge we can say. I can say this as a 100% hinge, but I cannot say this as a 100% hinge. Okay. Let me say not possible. 100% not possible. Because यहाँ थोड़ा तो मुझे I need to cut this web little for putting the bolt, and I should have some edge distance like this. So there will be some force possible. There will be some, this wave will try to resist the horizontal, and there will be little force here. And you know that when there is a force, ये कौन कर रहा है? ये portion है ना, ये portion. This is connected to this column. So there will be little force and there will be some distance. So I would say it is partially fixed. Okay. See, with these concepts are little, maybe, I don't know, try to understand, but partially fixed. Because ये F into D रहेगा ना resistance. Yes or no? समझ में आ रहा है कुछ?
Yes, sir.
But whenever I do the analysis, I assume it as a hinge support. I do the design as a hinge and I do the detailing like this. Now अभी मैंने hinge तो analysis में assume किया है, design भी कर रहा हूँ, लेकिन यहाँ तो कुछ तो थोड़ा force develop हो रहा है, यहाँ हो रहा है कि नहीं? कुछ तो force होगा क्योंकि ये तो depth है, यहाँ कुछ तो there is some depth here and this wave is connected to this column, so there will be force here, there will be force here, and there will be distance here. Now still I am saying that it is a hinge. Can anybody explain ये कैसे hinge है?
So the movement is very small because the
Moment is
distance d is very
correct,
small.
correct. You are correctly pointed out. So d is very, very small. So d is almost near to 0, I would say. It's not 0 exactly, we can say. But looking at the total picture size, it is very small. And as it is, d is very small or near to 0 or very, very small. Very small. So that means f into very small value will be near to 0. Yes or no?
Yes, sir.
Therefore, it will not offer any moment, or it will offer very small moment. And when I say very small moment, why not to assume it as a 0 moment, right? So there are certain errors, certain assumptions in structural engineering. We have to do that. There is no other choice. And that's why I can say this, I will ignore this as it is very small. So I am ignoring in my assumption. And let's say it as a hinge support. I hope all of you got this. कैसे कर रहे practice में? Got it? ये practically possible नहीं. This is theoretical picture. It's practically ऐसे beam को I section को ऐसे curvature वगैरह करना. We don't do that cutting और ऐसे करना possible नहीं है practically. So did you get this hinge? So ये मेरा hinge connection है. Okay? Again here also I will do the same thing. ये सब ये निकल के वही रहेगा. अभी forget this. अभी मैं इसको fix करना है हमें. अभी same connection you will create here and I can say both supports are hinge supports. अभी यहाँ भी ऐसे किया, then it will be hinge support. Both supports are hinge. I can say this beam is a simply supported beam. And how we draw the simply supported beam? Mathematical model कैसे रहता है? So how I draw the hinge support? अभी books में आपने देखा है. We draw the beam hinge support like this. Yes or no?
Yes, sir.
So this is the presentation of hinge support. And this beam is having some load. Okay. And having some span. समझो ये span है L. So I can represent this practical beam. ये L है. By arranging this practically, and I can say that it is a hinge support, and I will then analyze this beam and so on, simply supported beam. Now, if you want to make this, अभी hinge भी draw करो क्या? So this is your hinge support, both hinge. Now let's go and try to make this as a fixed support. कैसे बनाना है पता? I'm giving little more time for these concepts because we have seen that many candidate students, they make mistakes here, and the mistakes are because they don't know the concepts. Okay. So I hope this batch or our batches should not create any mistake because they don't understand the concepts. ये हमारा थोड़ा ये चल रहा है. बताओ अभी इसको मुझे फिक्स करना है, कैसे करेंगे? फिक्स मतलब क्या?
So
Let's make it
there
fix.
will
Yes. So there has to be somebody who will resist vertical reaction. Possible है, चाहिए मुझे, ये चाहिए. So it will not move down, it will not move right or left, and it will not rotate also. Okay. So there has to be moment also. ये तीनों चाहिए मुझे resist करने के लिए. क्या करेंगे यहाँ?
वेल्डिंग करेंगे.
See, don't use the word welding, because see, I have seen many candidates saying that whenever you want to make it fix, do it welding. अभी समझो इसको भी मैंने वेल्ड किया. It's good. अभी अच्छा हुआ. अभी मैं instead of bolt, चलो इसको मैं क्या करता हूँ, don't put the bolt here. So I don't want, I will weld here. यहाँ एक वेल्ड बना करता हूँ मैं, यहाँ एक वेल्डिंग करता हूँ. Let's do welding over here. Is it fixed? Yes. Is it fixed?
No, sir.
Why?
Because area is very small to resist load.
Area means we can say this distance. This
हाँ,
distance is
distance.
very small,
हाँ,
because this distance and then this, sorry, then this F, and there is a F here, and F into D is very small. So even though you are welding this, there is no sufficient depth available here to resist the moment. क्योंकि D अगर बड़ा रहेगा तो ही moment resist होगा ना ज्यादा. Yes or no?
yes, sir.
Yeah. So don't use the word welding. You cannot make the fixed connection by welding if you don't observe this concept. Okay. अभी I think you got enough hint to make it fix. अभी कैसे करेंगे fix?
So we can use two bolts having more distance.
Okay. ठीक है, थोड़ा मैं ये करता हूँ. Okay, let's go with your concept first. So यहाँ एक बोल्ट करता हूँ मैं, यहाँ एक बोल्ट लगाता हूँ. Let's say I have one bolt over here, one bolt over here. Okay. Is it fixed? Or is it a good fixed connection, I would say? Is it a good fixed connection?
no, sir.
Why? First of all, this distance is small, but there is a fundamental, we can say, concept or mistake in this connection is in fixed connections. See, fixed connection, fixed moments are developed where in beams. So whenever beam bends, what happens? Let's discuss now again. So this is not good connection of the fix, because it is connected to this bolting is done to the web of this beam. ये हमारा web है ना, and all of you know that web generally takes the most of the shear and not the moments are taken by the flange. So please keep in mind, if you want to make the fixed connection, first of all you should connect the flanges to the column. So connect this first. Because whenever there is a load on the beam bends. Okay, so if you want to make it fixed का कनेक्शन का फिलोसॉफी क्या था हमारा, ये हॉरिजॉन्टल जैसे है वैसे ही रहना चाहिए यहाँ, राइट? ये 90 डिग्री मेंटेन होना चाहिए, यहाँ भी सेम ही होना चाहिए 90 डिग्री, and then it will bend like this, then ये 90 डिग्री again. Similarly this will bend from here ahead and ये 90 डिग्री. And वो whenever there is a bending, यहाँ क्या होगा, as it is not bending, यहाँ टेंशन डेवलप होगा क्या नहीं? टेंशन, yes or no?
Yes, sir.
This top flange will have tension here at near the support, क्योंकि this is not rotating. यहाँ क्या होगा? So यहाँ टेंशन है, यहाँ क्या होगा?
Compression.
So यहाँ compression है हमारा, यहाँ क्या है? टेंशन. और ये
Tension.
सपोर्ट को टॉप पे क्या रहेगा?
Tension.
ये टेंशन.
Tension.
So here यानी यहाँ अंदर
Compression.
compression, right? That means, see how you understand. This will try to go out and this will try to rotate also. अभी ये थोड़ा समझ के लिए. This will try to rotate, but I am making this 90 degree. I am creating such a arrangement over here, fixed connection, so that it is not bending. So there will be यहाँ tension मेरा develop होगा because this is not bending here. So there will be tension at the top. And where this tension is getting developed, what is the region? So the tension gets developed in the flange. Okay, या flange में होगा tension. So I need to connect, because ये tension को resist करना है, then I need to connect this here. Then and then this tension. Now ये fixity कैसे करना है मुझे? ये tension, whatever the tension is getting developed, I want to transfer this into the column. I will provide one more plate over here. या कुछ तो plate चाहिए मुझे. Then I can have, as you said, either you can have a plate like this, ऐसे plate करो, ऐसे plate, and then you put one more bolt here, ऐसे bolt लगाओ. And you should also have a plate like this, ऐसे एक plate करो, so that अभी क्या हो रहा है? This tension is transferred here. ये, this is your tension. ये from flange, from this flange it will transfer to this plate. So there is a T over here, and this there is a compression here C. So this will transfer here C. Okay. समझ में आ रहा है कुछ?
Yes, sir.
Because I am connecting this flange to this column. That means whatever tension which is trying to get developed will develop there. क्योंकि मैंने यहाँ connect किया. In hinge what we did? We have not connected this. Please see this gap. I am not connecting. Therefore there is no possibility of any tension to be developed. Tension होगा ही नहीं, क्योंकि tension develop होने के लिए support में transfer तो होना चाहिए उसको. Support में कहाँ जा रहा है यहाँ? Gap है ना? As there is a gap, this tension cannot transfer here, and as it is not transferring in the support, tension cannot develop in hinge here. T is 0. And again here C is 0. So ये जो T है, let me draw it first. So ये भी C 0 है, and as the C and T are 0, that means the forces T and C, T मतलब 0 है, T into ये समझो distance है तुम्हारा D, capital D करता हूँ. So T into D is moment अगर होना होगा तो, लेकिन T value 0 है, so 0 into D will be 0. That means there is no possibility of any moment in this case, क्योंकि ये T होने के लिए इसको connect तो होना चाहिए, इसको transfer होना है ना support में. So यहाँ there is a possibility of tension to be developed as we are connecting this flange to this. So, and this will transfer through this plate in the column, and the compression will transfer from this plate here. Okay. And there is good depth available, enough depth, capital D. So this T is possible, and there is also D, bigger D. T is possible because of this, as I'm connecting this flange. So the T into D value will be the moment at the support. Okay. So moment भी है, again I'm connecting this, either bolt करो या weld करो, there is no problem. So vertical reaction भी possible है, RV, and horizontal reaction भी possible है, RH, on both the bolts या supports. Okay. And this is your fixed connection, practically speaking. I hope all of you got this right. So if you want to create moment connection, create such arrangement which will develop tension and compression in the flange, and transfer this tension or compression through flange to the support. अब ये column मेरा support है, तो यहाँ flange, I will connect this flange and then I will create one more flange in the column also, so that यहाँ से मेरा force ये column में जाएगा. Got it?
Yes, sir.
And also create this D as far as maximum possible. जितना ज्यादा D उतना मोमेंट ज्यादा डेवलप हो सकता है, रेजिस्ट हो सकता है. And this support we call it as a fixed support, and we can mathematically draw the fixed supports. अभी इसको ही मैं दिखाता हूँ कि ये मेरा ऐसे दिखा सकता हूँ. So this is my symbol of the fixed support, fixed support, fixed support. And there is a load. Now, if I want to draw the bending moment diagram, we are going to learn the bending moment, but let me draw here. As it is a fixed, will there be a bending moment at the support? रहेगा ना? यही तो है ना ये वो.
Yes, sir.
So there will be bending moment at the support, then again at the here also at the center, and again there is a. So there is moment at the support, moment at the support, and moment at the. Sorry. Let me write down as a. So यहाँ भी moment है मेरा, because ये C और T यहाँ भी possible है ना, ये C और T, but यहाँ C है और यहाँ T है, इसके लिए moment diagram मैंने I have drawn it at the bottom because tension is at the bottom. Here the tension is at the top, so I am drawing the bending moment at the top. Okay, so that this is, we call it as a fixed beam. This is fixed beam mathematically, and this is fixed beam practically. So if you analyze this beam like this, then you should detail out this like this. And if you analyze the beam like simply supported like this, what will be the bending moment? यहाँ कितना रहेगा bending moment? Moment कितना रहेगा? It is a hinge.
Zero.
Hinge.
It supports the 0.
Support 0 रहेगा. So because it is a hinge, so moment is 0. All of you know at support. Now if you want to analyze like this, make sure that you are detailing like this. Then and then your assumptions of the analysis match with the real structure. Concept समझ में आया supports का?
Yes, sir.
Now there will be one more question. अभी ये तो steel structure में हुआ, फिर RCC में कैसे करना है? I'll just finish with that problem and we'll close our session. Now if I want to create fixed support in RCC and hinge support in RCC. Let's say this is your RCC beam and RCC columns. Now, how to make this fixed? So fixed means this moment. Okay. So there has to be moment to be resisted at the support. So you should make such arrangement which will resist the moment. भी बताओ कैसे करना है. So we have already seen कि अगर मुझे ये moment करना है at the support, so top में मुझे tension develop करना होगा. I need to develop tension at the top and transfer to the support. I need to develop the compression at the bottom and transfer to the support. Okay. Yeah, are you getting this? Create tension at the top and transfer to the support. Create compression at the bottom and transfer to the support, near the support. Okay. So how we create or transfer the tension in RCC beam?
By providing reinforcement.
So by providing reinforcement, we are resisting the tension or transferring the tension. So I will, yes. Oh. So this reinforcement, all of you know that it can take tension. This reinforcement has a capacity to take the tension. So this reinforcement can take tension and definitely it can transfer the tension in the concrete. अभी यहाँ ये हो रहा है, समझ आए? So if I transfer this in the column and this is not sufficient to transfer, there has to be some additional length. तो ये tension मेरा ऐसे transfer होगा यहाँ से यहाँ. Getting? Yes or no? यहाँ भी वैसे ये टेंशन यहाँ सपोर्ट पे और ये टेंशन कॉलम में पास. Now let me draw compression reinforcement also. So compression there is no problem actually because compression के लिए यहाँ concrete भी है. Don't forget there is a concrete here. So whenever I draw, don't forget there is a concrete. And concrete has having what? Compressive capacity, yes or no?
Yes, sir.
That means it can take compression. So अभी ये क्या होगा? Beam क्या? What will happen to this beam? So whatever compression is trying to develop, it will be resisted by the concrete. So this is nothing to do with this reinforcement. For the time being, let me delete this. I think so. This one. But okay, let's consider this line is a line of compression in the concrete. Okay, so there is a compression possible here. ये compression possible है due to concrete and even reinforcement is also there in RCC beams. So which will take the compression? Let's say there is a reinforcement, it will take the compression, and the concrete will also take the compression. So this T is there and this C is there. And there is a D also, don't forget. Okay, D भी है ना, and quite sufficient depth रहती है ना beam की. So as there is a T and there is a distance D, that means there is a moment possible, resisting moment possible at the support, and therefore I can say that this is a fixed support. Getting? Hello?
Yes, sir.
Now in reinforcement, actually there is one more point, that to transfer the tension into the column or support, there has to be sufficient length. यहाँ से यहाँ तक. That length we generally call it as a development length.
Gap length.
No, development length, LD. So यहाँ से यहाँ तक रहता है वो. And then this tension can be transferred. Sufficient length चाहिए, LD. That length is LD. And then I can say that I am analyzing this beam as a fixed beam, and this moment S is resisted. See, this is the moment developed due to the loads. ये WL square by समझो 12 है. ये W है समझो. So this moment is resisted by this resisting moment T into D. So I will provide sufficient steel, and D is there. It is, let's say my depth of the beam is समझो 500 beam है और 0.5 meter depth of beam है समझो, तो D is known to me, and I will provide steel such that I can resist this moment. Yeah. So this is your fixed support.
Yes, sir. Yes, sir.
Now there is a problem question, how to make it as a hinge support. I will give one theoretical example first, which is not done practically. But as a if you really understand the concept, you can give me that theoretical solution. है किसी के पास?
On the top.
So, abhi, why this moment MR is possible? Resisting moment, why it is possible? Because there is T available and there is D also available. Okay. If you want to make this MR as 0, अगर आपको MR 0 करना है समझो, क्या करेंगे आप? Either T को 0 करो और D को 0 करो, right? Either 0 into D is 0 or T into 0 is 0. Yes or no?
Yes, sir.
तो अभी कंक्रीट में प्रॉब्लम क्या है? हाँ, तो यहाँ D 0 करना होगा तो कैसे करेंगे, या T 0 कैसे करेंगे? That means ये दोनों बार का डिस्टेंस मुझे 0 करना है. I want to create D as 0. So if I want to make the distance between these two bars as 0, कैसे करने का हमने? Any idea?
Entire section should be in compression only.
No. See, our beam is like this. Beam will not change. If I want to create this distance between the two bar as 0, कैसे करेंगे? तो आपने, you might have seen sometimes, yeah.
It's not possible.
No, it's possible. ये देखो कैसे. हुआ क्या possible? Oh, sorry, ये right side. ठीक है, right side I'm not showing. Just show the right left side. Okay. Is it possible or not? यहाँ क्या हो रहा है near the support? 0 है ना distance? दोनों बार का. Yes or no? तो this T डेवलप होने का ट्राई करेगा और यहाँ 0 होने की वजह से ये हिंज क्रिएट हो जाएगी. And ये जो whatever concrete is there around it, it will crack. Yes or no?
Yes, sir.
So if there is a load and it will try, see ये tension यहाँ से यहाँ ट्राई करेगा ट्रांसफर होने के लिए, but यहाँ कुछ नहीं दो, it will crush. All of you know that tension, the concrete cannot take the tension, so it will crush over here. As it will crush, खत्म हो गए. It will try to go here, but here there is no resistance available due to this 0 distance. So that means I can say this concrete will crush means it is a hinge. So in RCC, the hinge gets created by cracking of the concrete at the support. If you see any cracks at the supports like this, then you can say your beam has become simply supported, or the support has become hinge support. So hinge indication in the concrete structure is crack. If you really want to make it as a hinge support, you need to create such an arrangement. Purely hinge, I am trying to say, more of the hinge. Then this has to be arrangement, and if there is a load, this will crush. And once it gets crushed, or once it gets cracked, then and then hinge will form. But in reality, in practice we don't do such kind of connections, because if you see any cracks in the beams, will you really feel good? आपको अच्छा लगेगा क्रैक दिख रहा है, स्ट्रक्चरली ये स्टेबल
No,
है,
sir.
but you will not feel good. That means it is a serviceability issue. क्रैक हो रहा है मतलब सर्विसेबिलिटी का इशू है. You are not feeling good, you will feel scared. अरे क्रैक हो रहा है मतलब स्ट्रक्चर फेल होने वाला है. See, I have detail like this which is structurally correct, but serviceability issue होगा, इसलिए ये डिटेल, this detail is not done in reality. So how we do the detailing? So we do, मैं right side को दिखाता हूँ. So let me, this was the theoretical hinge, and practically we cannot create 100% hinge connection, but yes, I will keep this bar like this. यहाँ से यहाँ तक लेके जाऊंगा मैं, ज्यादा आगे नहीं लूंगा. So I know that if I want to make it fix, यहाँ से ये turn करके यहाँ लेना है मुझे, so I need to provide full LD so that this full tension can develop. But in this case, what I will do, I will not provide this bar like this L. थोड़ा आगे जाके छोड़ दूंगा. I will take this bar little ahead and then we'll keep as it is. यहाँ हमारे shear reinforcement वगैरह, all of you know this. Just keep in this mind. So I would say that you are not providing enough LD so that whatever tension is developing here will not transfer in the column and it will create hinge. Generally, this hinge connection is not 100% hinge, so we generally call it as a partially fixed. But it is near to the hinge, because I am not transferring this tension ahead. So near to the hinge, I can say. So it is hinge. So you analyze it simply supported, like this one, and you can do detail like this. Whenever we take practical problems and so on, we will discuss this. But conceptually, this is the case. So I think all of you have got this. Equilibrium, then supports. Yes?
Sir, I have one doubt.
Yes, please.
Sir, when we think about this continuous beam in RCC slab, RCC,
Mhm.
how the support will be active?
Okay, as you are asking the question, we are going to discuss, but let's see. When there is a continuous beam, let me draw that first. Two span continuous. Let's draw this. Let's say this is a two span continuous beam. Now, what will be the bending moment diagram for this? We are going to discuss bending moment diagrams, but as you are asking, let's discuss on that also. If you make it fixed, then these two fix, because, and there will be continuous support. Generally we show like this. Okay, as it is a continuous, I'm showing like this. Now due to the load, what will be the bending moment at the fixed support, and then like this, and at the support, continuous support like this. Now what is your question? Hello.
Yes, sir. At the middle, how support will be simply supported or fixed? How
It is having a moment.
Yeah, now it is like fixed.
Yeah, why it is moment? Because the moment from this left side is transferred to the right side beam. So there is a continuity available. If I draw the deflected shape of this beam, let me draw the deflected shape first. So if you want to understand any behavior of the structure, first try to understand the deflected shape, because that we can see with our eyes. I cannot see the bending moment diagram. It is a mathematical diagram. I think all of you know Bending moment is a mathematical diagram. It is a graph of bending moments at different sections. But if you see it physically through your eyes, then your deflected shape will be, then there will be curvature like this. Okay. Getting? So there is a like this concave or convex. क्या बोलना है इसको? Name doesn't matter. If this is the curvature, this is the curvature. Yes or no? So as
Yes.
this is a
Yes, sir.
curvature, there is a tension at the top. As there is a curvature like this, there is a tension at the bottom. समझ में आ रहा है कुछ? And this, whenever you can imagine the problem is, you take a model of the beam like this, put your load by your hand or something, you will see that this will be the deflected shape, and as there is support over here, it will continue to the next beam also, and due to that this moment is getting developed. Okay, so moment here. So it is hogging moment. Generally, we call it as a hogging moment, and this is sagging moment. Yes. Getting?
Yes, sir.
So there is a question whether shall we call this support as a fix or what? You may call it as, it doesn't matter, but it is a continuous support which has a moment. So if you want to give name to it, you can say continuous fixed support. Doesn't matter because there is a moment here at the support. Generally, we use the fixed word at the ends, but for the this portion, we say it is a continuous support, and whenever it is a continuous, there is a moment, definitely, yes.
Okay, sir.
And if you want to detail it out, कैसे करेंगे ये moment? आया problem तो करेंगे. So as this, I want to resist this moment, bending moment. I will, for resistance, कैसे करेंगे resist?
Extra
I
reinforcement.
will provide this
Negative
reinforcement.
reinforcement.
Yeah, so ये मैं tension reinforcement ये ऐसे मेरा develop होगा. LD. अभी यहाँ करना है मुझे ये resist. तो यहाँ I will provide this tension reinforcement. Okay, so this tension reinforcement will take the tension here. Again here same. यहाँ से यहाँ तक. At the bottom, I will provide tension reinforcement here. At the bottom here. और यहाँ क्या हो रहा है? यहाँ टेंशन है और टॉप को क्या रहेगा यहाँ? कॉम्प्रेशन. यस और नो? यहाँ कॉम्प्रेशन रहेगा. सी यहाँ सी यहाँ सी. Got it? Now in RCC structure, actually we are not putting compression reinforcement most of the times. The compression is taken by the concrete available over here. So even though I am drawing this line, but generally this steel is nominal steel and there is a concrete which is taking the compression. So यहाँ a concrete layer है हमारा compression force. Got it? Right?
Yes. Okay.
Yes, this is a continuous beam.
Yes, sir.
So next time we will start with the how to calculate the reaction of beams and how to draw the bending moment diagrams and so on. Okay. Mathematically.
Okay.
So we can say we'll start with the analysis next time.
Okay.
Yeah. So shall we close the session?
Okay.
So thank you all.
Thanks.
Sir, I have a doubt in the simply supported RCC beam.
Okay, please.
Fixed one. So,
Yeah.
Yes, sir. Yes,
Ah,
sir. In this, sir, I have a doubt, sir. The upper portion, we generally see if the load comes, it will be in compression and the lower will be in tension. But you
Here.
have provided the entire tension on the upper face
No,
only.
it's not entire. Okay, let me. Sketch wise, it is wrong. Now it is right. Okay.
Yes, sir. Now it is clear.
As generally, we provide the reinforcement for tying the stirrups, but the main reinforcement is this and
Yes,
this.
sir.
There
Now
is a
I
reinforcement
understand.
over here, but it is of no use because there is a compression there.
Yes, sir.
Yeah.
That's my doubt. Now it is clear.
Yeah.
Yes.
Thank you.
Thank you, sir.
Thank you and good night all.
Thank you, sir.